Hello students, we are solving the IB Math A HL past papers and currently we are solving the IB Math A HL November 2021 paper 1 and today we will be solving question number 9 of this paper. You will be getting the links to all the previously solved questions of this paper and of the other papers in form of playlists in the description area. So without any further delay, let us start answering question number 9. The maximum mark is 7 and the question says, consider the expression 1 over square root of 1 plus ax minus square root of 1 minus x, where a belongs to the set of rational numbers and a is not equal to 0. The binomial expansion of this expression in ascending orders of x as far as the term in x squared, because they will be infinite series. So we have to go as far as the term in x squared is 4bx plus bx squared, where b is another rational number, a is a rational number, and b is also another rational number. Okay. So part A says find the value of A and the value of B. Okay, so I hope you remember the binomial expansion terms, but okay, I'm writing the first three terms because we need up to x squared, so I'm writing only the first three terms. Okay, so it will be 1 plus, because if the first term is not 1, we have to make it 1, but over here the first term is 1. So I'm not taking that part, that what we have to do if it is not 1. It is 1, so I'm writing it as 1. So if it is 1 plus, say, ax whole to the power of n, where n belongs to the set of rational numbers, will be equal to 1 plus n times ax plus, over here I'm coming, n times n minus 1 over factorial 2, which is 2, ax whole square, and plus dot dot dot. It is an infinite series. Okay, so we have to expand these, both the terms, the first term, the second term. And what do we have as the first term? We can write 1 over square root of 1 plus x as 1 plus ax, rather, 1 plus ax to the power of negative half. I have brought this to the numerator part and I cannot keep the radical sign. I have to change it to power indices form. So it is 1 plus ax to the power of negative half minus 1 minus x to the power of positive half. Okay. So this is equal to, if, and over here n equal to negative half, in this case n equal to positive half. Okay. So let us write the first three terms of the first three terms of the expansion. So it is 1 plus n times ax. So it will be, n is negative half in our case. So it is negative half times ax, it is ax, and plus n times n minus 1. So it is negative half times negative half negative 1 over factorial 2. So I'm writing it as 2, or I can write it as factorial 2 as well for the first time. And it is ax whole square. Okay, plus dot dot dot. Okay, and then minus, and the first three terms of the second expansion, it will be 1. Now, in this case, a value is equal to -1. Okay. So we have 1, and then in value is half, so it is half plus half times exe is -1, so it is negative x plus half times in minus 1, that is half minus 1, and over factorial 2, ax whole square, that means negative x whole square, plus dot dot dot. Okay. So this is equal to, actually this one is a part A that I am answering. So it is 1, and this is negative ax over 2. And this one is negative half, and this is negative 3 over 2. And negative half times negative 3 over 2 will be negative times negative is positive. So it is positive, and half times 3 over 2 is 3 over 4. And there is this 2 in the denominator. So 3 over 4 times half is 3 over 8. Okay. So it is 3 over 8. 3 over 8 a square x square. And I'm not writing the plus dot dot over here. I'll be writing the plus dot dot at the end. So it is -1. And then this is minus x over 2, and there is the minus sign in front. So it is plus x over 2. And this one is minus x whole square is x square. And this is half minus 1 is minus half. So half times minus half is minus 1 over 4 times 1 over 2 for this 2 in the denominator. So minus 1 over 4 times 1 over 2 is negative 1 over 8 times by this leading negative sign. So it is positive 1 over 8. So plus 1 over 8 x square and plus dot dot dot. Okay. Now let us just group the like terms. So it is 1. Okay, sorry, not the 1. The 1 will not be there. And first of all, we have to group the terms containing x. So it is x, and this is half. So let me write the half plus first because it is a positive number. No other reason. So half, and this one is minus a over 2. And for x squared, both are positive. So, okay. Plus x squared and 3 over 8 a square plus 1 over 8. Okay. So, we have, see, it is 4bx plus bx squared. So, therefore, b is equal to, or 4b rather, 4b is equal to, because 4b is the coefficient of x, 4b equal to half minus or 1 minus a over 2. Okay. Therefore, b is equal to 1 minus a over 8. Okay. And we are seeing bx square. So the coefficient of x square is b. So b is equal to, from here, b is equal to 3 over 8 a square plus 1 over 8. Okay. And b is also equal to 1 minus a over 8. So let us just equate this expression to 1 minus a over 8. And I am multiplying the entire equation, this part, by 8 because every term is containing 8 in the denominator. So I am multiplying the whole equation by 8 to get 3a square plus 1 equal to 1 minus a. Okay. So this is giving us 3a square minus, plus a equal to 0, or a equal to 3a plus 1. A times 3a plus 1 equal to 0. So either a is equal to 0 or a equal to negative 1 over 3. Okay. So if a is equal to 0, then you will not be having this term ax. You will be just, if a is 0, so you will be having this square root of 1, which is 1. So the first term will be 1 over 1, simple 1. You will not be having this denominator binomial expansion. Okay. So a cannot be equal to 0. So this should get rejected, and a equal to negative 1 over 3. So what is b? So b is equal to 1 minus a over 8. Therefore, b is equal to 1 minus of minus 1 over 3, because a is negative 1 over 3. So it is plus 1 over 3 over 8. So this is 3 over 3. 3 over 3 plus 1 over 3 is 4 over 3. So this is 4 over 3 times 8, which is equal to 1 over 6. Okay. So a is equal to negative 1 over 3 and b is equal to 1 over 6. Okay. And what about the part B? Let us solve the part B over here. Let me just take another color because I don't have much space. So I'm taking another color. Okay. Okay. So first of all, we take this expression 1 plus a for 1 plus ax, that is negative 1 over 3x raised to the power of negative half. Negative 1 over 3x should be between negative 1 and positive 1. Okay. So if we multiply all the three parts by negative 3, okay, be careful. We are multiplying all the three parts by negative 3. So the inequality signs will be getting changed because we are multiplying with a negative number. So that is why we are getting this negative 1 times negative 3 will be positive 3. So this is 3 and then it is this way. Negative 1/3 times negative 3 is positive 1. So this is x. And 1 times negative 3 is negative 3. So this is this. So x is greater than negative 3 but is less than positive 3. Clear? From this one. Okay. Now I don't have any space below, so I am writing over here. For this one, it is 1 minus x to the power of half. For this, we have negative x to be between negative 1 and positive 1. Again, now, because we need the interval of x, not negative 1/3 x or negative x. Okay, so we have to get the interval for x. That is why we will be multiplying all the three parts by negative 1. Okay, this time. So negative 1 times negative 1 will be giving us positive 1, and since we are multiplying by a negative number, the inequality sign will be getting changed. It is this way. Negative x times negative 1 is positive x, and 1 times negative 1 is negative 1. Okay, so one of the inequalities is this, and the other is negative 3. Okay, so which one is the common region between both of them? Obviously, this is negative 1 to positive 1. So this is the answer for the subpart B. It is negative 1 less than x is less than positive 1. Or you can write, or else you can write this as absolute value of x is less than 1. You can write it this way as well. Okay? Whenever you have two expressions, you have to check the region of convergence, interval of convergence for both of them. And you have to take the common interval. Okay? So we have completed answering question number 9. And I'm Nilanjana Sanyal. I am an online math tutor for IB Math A SL and IB Math A HL students. I tutor both within India and outside India. And I am starting small group online sessions for new IB Math A SL and IB Math A HL students. Why I'm saying the word new? Because this is only for the grade 11 students. I'm not taking the grade 12 students who will be having their board examination in May 2024. Okay, so in case you are interested in joining my group sessions, you want to know more about these group sessions, you are seeing my WhatsApp number getting displayed, you are seeing my email ID getting displayed. You may contact me for more details. Okay, and thank you for staying with me till the end. We meet again very soon in our next session, where we'll be solving question number 9 of this same paper. So till then, bye.